connectivity within a group. And each clique or clan, if you like, has a leader who, again, has no way of knowing that they're the leader. Nobody knows that this is what the structure looks like. But that leader has, loose connections to the leaders of two neighboring cliques, okay? So you might think of this like many of these kind of artificial social network models. This is kind of a cartoon of a highly tribal society with only loose interaction and connections between the tribes. And so when the rewiring parameter Q is equal to 0, the network generated is exactly this network deterministically. But when Q is non-zero, you basically go to each one of these internal clique edges and flip an independent coin. And if it comes up tails, let's say with probability 1 minus Q, you just leave the edge there. But if it comes up heads, you're going to rewire that local clique edge to a long distance edge. So you'll basically pick one of the two endpoints of that edge randomly, delete the edge, and then give the chosen vertex a random edge to an arbitrary member of the network. Okay? So like many of these models, if you've seen them before, this parametric model lets us smoothly go between two extreme worlds. One is this highly tribal society, and then if I set Q equal to 1, actually this initial structure is a complete red herring, and I really just have a random graph with the same number of edges in it, right? A completely unstructured, random, Erdős-Rényi style network. And if I set Q to some value in between, then of course I'm getting something in between, and it lets you go between the two. So before I talk about the comparison or of coloring the consensus, I just want to again give you a sense of what these experiments are like. And so what I'm showing you here are for several consensus experiments in which the value of Q was either 0 or something pretty small like 10%. So it means that this tribal structure is largely in place with perhaps a smattering of these long distance edges. I'm showing you visualizations of such small Q experiments, and what these visualizations are showing is time is running across the x-axis. For each of the 36 players, there's a row. And the color in the row is simply showing what that player is playing at that particular moment in the experiment. And because this clique structure is largely in place, it makes sense, of course, for me to arrange the rows in groups of 6. So the first 6 rows correspond to this clique, the next 6 rows correspond to this clique, so on and so forth. Okay? So you can immediately see vestiges of course, a very sensible kind of